Let's do another example. This time we'll look at how many bit strings there are of length 10 that have exactly 3 ones. Remember, bit string is just a string of zeros and ones, so here would be an example of that. I guess we have 10 there. This one right here is a 0. It looks like a 6. So there's an example of one right there. So maybe pause and think about what is it we have to decide here to create such a bit string. What is it going to be characterized by? Okay, so pause and think about it. I'm going to go ahead now and continue. So what characterizes this bit string is where the ones are among the 10 positions of that we have here. And so if you just say which positions the ones are in, for example, the ones in this one are in positions 3, 5, and 9. It doesn't matter which order we put those in. That's the same as if we had said 9, 3, and 5. Same. So what characterizes it is the positions we've chosen out of the 10 available for the ones. So there are C10, 3, the number of ways to choose 3 out of 10 things, or 10 choose 3 is the way this is often read, such strings. And you could write that out as it's, I didn't say that we needed to do that, but that's the same as 10 times 9 times 8 over 3 times 2 times 1. Just to remember that there are 3 things on the bottom, and so there'll be 3 on the top starting from 10 down. And so if we get that, we'll get a 3 canceling and a 4. That's 12 times 10, so 120. Yeah? Right, so let's try another one that's kind of related. How many ternary strings of length 10 have exactly 2 zeros and 3 twos? Now, a ternary string, the ternary is from 3, so there's 3 different entries that can be in the ternary string, 0, 1, and 2. And so in this case here, so what we're going to do is we'll say that we will, as above, first pick the positions of the zeros. There are 2 of those, and there are 10 choose 2 ways to do that. And then second, pick 3 of the remaining positions for the twos. So that would be, there are 8 remaining, so it would be 2 choose 8, like so. And then, while we don't have to do this, it's kind of interesting to see what this does. I'm going to say, okay, now choose third. We'll choose 6 of the 6 left. So C6, 6. Okay, we don't really have to choose them. There's one way to do that. You have to put the twos in the remaining, or the, I guess it's the ones, for the ones, because the twos we put here. And I have a mistake there, don't I? Let's go back and change that to a 3, because there's 3 that I chose here, and these are just 5s now, yeah? Okay, so 5, yeah, okay, that's what it should be there. Right, so one that's very similar, let me scroll this up so we catch it for sure. How many strings of 10 lowercase English letters, now these are lowercase English letters we're working at, have exactly 2 G's and 3 V's? So this is very similar in that in the one above we had the, we're going to put zeros in there and 2's in there. Here we're putting G's in and V's in. So in very much the same vein, they have exactly 2 G's. So it's the spots that we can pick to put those G's in. It's not at least 2 G's, or at most, it is exactly 2. So the first thing we'll do here is pick the spots for the G's, and there are still 10 spots. 10 choose 2 spots for G's. And then of the remaining 8, 3 of those will be chosen for the V's. Spots for the V's. I could have chosen the spots for the V's first and then the spots for the G's. It'd be the same number. Now, in this case here, the remaining spots aren't specified. That is, the remaining entries aren't specified because they can be any of the other lowercase English letters. So I guess I'm going to break this up into some blanks here. How many blanks are there? Well, there's 5 other spots. So we'll do these in order, left to right, say. And we can use any of the other English letters. So it's 24, 24, 24, 24, 24 in those spots there. So that's what we'd have right there. And if we wrote this out, this would be 10 factorial, sorry, over 2 factorial, 8 factorial, 8 factorial over 3 factorial, 5 factorial, and then 24 to the 5th, just to illustrate the factorial way of writing that out. We could have done the same thing in the one above, and I'm kind of inclined to go back there to show you something there. So if we wrote this in factorial notation, I'm going to have to make this a little small to squeeze this in here. It'd be 10 factorial over 2 factorial, 8 factorial, 8 factorial over 3 factorial, 5 factorial, 5 factorial over 5 factorial, 0 factorial. And the thing is, the 8's cancel, and so do the 5's here, and that will always happen in this way in such a problem, leaving us with 10 factorial over 2 factorial, 3 factorial, 5 factorial. And notice what we did is we picked of the 10 spots, 2 for one thing, 3 for another, and 5 for another. So the 2, 3, and 5 add to 10. That's pretty cool how that works, and that's a general sort of principle we'll encounter a little bit later as well. So I'm going to try one more problem in here. Actually, I think I'll take a break, and we'll come back and do this next problem.